Howdy everyone, it's me again, and this is my first update video for my Phase 3 journey, if you will, through the Flatiron Data Science Flex program. So, I made an introductory video just to like create a playlist for Phase 3. I started doing like a little bit of YouTube stuff about Flatiron when I was in Phase 2, and so I then decided that it would be cool to have sort of a playlist for each phase. From here on, it'll only be like 3 more phases, including this one right here. But there are multiple phases. Wrong page. Sorry. There's multiple modules in each phase. Right? Sorry, as usual, when I stream, my computer runs slower than molasses. So these are sort of each of the chapters, if you will, for all of Phase 3. So I have just last night, completed topic or module 21, which was pretty easy, not gonna lie. It was all about object-oriented programming, and so that was mostly review for me, because long before I ever started Flatiron, how I got into coding in the first place was this Udemy course. It was like a Python, zero to hero or whatever, master course type thing. And that went pretty in depth into like the ideas and techniques behind object-oriented programming. So pretty interesting nonetheless. There's a few things that were interesting to me, like towards the end of the module, they started to talk specifically about like OOP in the context of scikit-learn, which is a Python library that we've already used a lot, and we're apparently going to use a lot more as we move into Phase 3. Which, if you don't know, scikit-learn is basically a library with a bunch of like mathematical and statistical tools to do weird mathy, statistical, like machine learning type stuff. So my general process when I go through these modules, as far as note taking goes, I think it's good to. I'm all about like going paperless and being as like tech centric as possible, in the interest of efficiency. But I think it's important for me at least, to write things down by hand. That helps me kind of like retain the information better, as well as organize it in my mind better. Because something about writing it by hand, especially with pen, where I can't like erase it later, I'm a little bit more careful about how I phrase things in my mind before I stick them to paper. And that doesn't like I make typos and scribbles here and there, but it makes the final product a lot more coherent. So what I usually do is I leave this. Whoops, it's not wanting to focus. Yo, man, come on. I've got like my background blur to make it cooler for y'all. Okay, we'll just do that. So I leave this top section here for me to write out like how anything in the whatever module this particular paper is on. I try to condense every single module that I do into one paper, one sheet of paper front and back. I leave this like first front half of it to take notes later on for how like concepts in this module or other modules like connect with each other. This is the first module in this phase, so obviously this is empty. It usually doesn't fill in a whole lot anyway. But I like to leave it there. It just makes me a little bit more intentional about like the space that I do use when I write stuff. And this here is, I can't really hold it up to the screen because it's going to blur it out, right? But this is like bullet points, like broad strokes. What are like the major concepts and ideas in the module? So like, for example, like inheritance and object initialization and blah, blah, I don't strictly just write out like the names of each like lab here or worksheet, but it's a lot of that. Anyway, so like the big broad ideas, and not like any explanations or details about them, but just mentioning like what they are, right, and things I need to be aware of. And then back here, I go a little bit more into detail about the details of like what things are. Maybe I'll jot down like specific like functions or method calls or snippets of code that I want to remember and like that sort of thing. So for this video, I'm basically going to be reviewing my review sheet that I made here. So as usual, I don't like script or plan any of this ahead of time or anything, so I'll try not to ramble a whole lot, and I'll try to get through this in a relatively efficient and timely manner. And I don't necessarily have like a strong audience built up on YouTube yet, so it's kind of hard for me to gauge like what level of technicality to like go into. Like you know, eventually if the channel ever picks up, which I don't know if it will, mostly this is for my own like documentary purposes, but if people did start watching it, you know, I would be concerned with like, am I making stuff that's actually valuable to them? And that's going to depend on like, are these like technical people that are trying to advance like their already existing skills, or are these people that are trying to like get into it for the first time, or both, or you know, I don't know. So for this video, I'm going to approach this as if I was explaining this to somebody that doesn't know anything about programming, more or less. So let's go back to this joint here. I wonder if I don't want like my webcam to cover up the output. Yeah, that should be fine. Alright, so I'm in LeetCode here. I started like a playground thing, so this is just a lot easier to screen share than VS Code in terms of my computer like sucking air. So in Python, you have functions and methods and all these different things that basically make it so that you can reuse code later without having to rewrite it, right? And classes are sort of at the top of that hierarchy. So you can think of it like, so you have like variables, right? So a real classic example is like my list, right? And you assign a list of things to it, and there's different constraints that you have for different data types. Like a list, as you can see, can have like numbers or strings or different types of stuff. That doesn't do anything, right, that we see, but that thing, my list, does in fact exist somewhere. We just have to tell the computer to tell us. And there's a way to see like exactly where this variable like exists in memory and everything. I don't know that off the top of my head. We're not going to go into that right now. But the point being basically that you have data and you have objects, right? You have like things that the data is held within and that manipulates like the data. So a list is in Python a class. You can think of classes really as just like data types. So like you can call methods on a list. So you can see now that is added to the list. So this dot something and in parentheses, that's a method. And all a method really is a function. And we declare a function by saying def my function let's say it takes in some string, and we can do stuff to the string. And a string even is a data type or a class, if you will. So if I took a string in there and I wanted like a new string from it, equals, I can call a method on it. Strings you can use dot split on, I believe. Yeah. Which is going to make it a list. Some string dot split. And so here I'm passing in a parameter argument, same as I do for the function. When I call this function, I'm going to have to pass some kind of argument in here in the parentheses. Methods, it's the same thing. It's just a function that you have to pass an argument into it. Sometimes you don't. And the only difference between a method and a function really is that a method is bound to a specific class or type of data or type of information that exists, like in Python, right? So now I can print the fact that it's, well, just to make it a little more obvious what's going on. So print, you might have picked up on this point, is a function. So we can print my string, and that's just going to print that string. This is my string. But now I need to return with this, sorry. Return new list. Actually, let's call that string list because it's a list of strings. So this is going to return whatever's going on right here. So I can do a few things. I can print that directly. I can go like call my function inside print. And I can also do my new list equals and then call the function. And then put in, pass my string into it. So when I put my string here, Python basically thinks that it's like this is what it's actually seeing, right? And I can then print my new list. Get rid of all that. Don't need all that. So you can see that like my string initially is simply this, and we can call a function inside of another function as long as that function returns a data type compatible with the function that you're putting it inside of. So print, it's not a great example here because print will pretty much print anything. But you can imagine there's some functions that like only take in lists or only take in like integers or only take in list of integers or like whatever. So as long as your function, the return value, whatever function you're using as an argument, returns like the correct data type, Python will basically see it as like you just directly copy and pasting that return value into there as an argument anyway. So it's all the same. And just to make it a little more clear that we haven't actually mutated my string at all at this point, I think. Yeah. So you see here we declare like my string, this is my string, and then we do some stuff to it and we manipulate it, and then it returns this new value for us. There's a couple different ways we can do that. You can see that they do, the end result's the same thing, but the original piece of data, the original variable itself, is like uncorrupted at this point. There's also ways, and there's some data types that are, you have like mutable and immutable data types. That becomes a little bit more important with like classes and things. But you can also like directly manipulate certain types of data. So I think strings are in Python immutable. Let's actually Google this. And then mutable and so like sets are immutable, lists are mutable. Mutable meaning they can be changed, immutable meaning they cannot be changed or mutated, in other words. I just want like a good like graphic or something. Ultimately, you can pretty much manipulate anything the way you want in Python. You just have to do that with techniques that are respective to their here we go, to the sort of parameters of whatever data type they are. So same way you have like built-in functions like print. Print comes with Python. I don't have to write the code for print, but like my function here is a personal function that I wrote. So the same way, there's built-in data types in Python. Lists, text, dictionaries, numbers, which are, that's like a whole set of like number types. Strings, tuples, blah blah blah. These are all built-in data types in Python. And as you can see, some of them like you can change, others you can't. Now you can take like a list and you could like call like a join method on it or something. You could turn it into a string. You can, like I said, like with having enough code, you can do pretty much anything you want. But the idea basically is that when you want something to be not manipulated by the code, like you see with my string here, we can create things that are as if it was manipulated, but we still have the original value in its original form, which you can imagine would be useful. So if you want that, versus like sometimes there's things where you want to actually like change like the thing itself like as you go, and those are your like mutable types. So like I said, there's built-in data functions in Python. You can create your own functions. Likewise, there's built-in data types in Python, and likewise you can create your own data types. So the same way, maybe I don't want to like delete that. Yeah, whatever. So we have this keyword def when we're defining a function. When we want to define our own data type, we call class. And we don't need the parentheses here, unless we want it to inherit, which we'll get into that later. And if we want to not get an error, we have to put in pass, and whoops. Weird. That's why I don't use lead code as an IDE. don't know why it's just throwing an error. Like, I have no idea. Invalid syntax. Ah. Name. Oh. Let me just get this all set up. Cool. So as you can see here, I'm gonna clear that just so it's up at the top of the page. Printing my name out, right? So we're declaring this new data type for Python, right? Similar to a function, where like a function doesn't actually like do anything on its own. You have to actually call the function and actually pass arguments into it. Likewise with a class, when you define a class, you're just sort of telling Python what's the design. You're handing Python to the design documents, if you will, for this new like data type that you want. But for anything of that data type or class to actually exist and actually be passed around and used in Python, you have to instantiate an object of it. You have to actually initialize some instance of that class. So right here, just like we define a class, we're also defining, just like we define a function, we're also defining a class. We want to be able to do stuff to that class, right? So we're defining a function within it. Don't worry about the dunder in it thing right now. So we later on will call that a method, right? Because this is a function. That's all it is just a function. But it only can be called on this data type or this class, right? So I create some variable name to hold it, right? So that I can call on it later. And I set that equal to some instance of my class, right? Or whatever the name of your class is. So then here, the same way we can, like I showed you earlier, we can call functions inside the print function as long as it returns an appropriate data type and blah, blah, blah. We're calling a method, the name method, which we've given it the information for right here, on this instance of our class object. So you'll notice I just have like a bunch of names. So right now this is a blank canvas, if you will, but we've defined like the shape and conditions of the canvas, so to speak, right? So all this dunder init thing means is that like we're going to declare this stuff upon initialization. So that's why it threw an error earlier and it required me to pass in an argument. So self, you'll see that I only passed the one argument in here, but I have two parameters passed in here. All this self is basically telling the function that the first argument passed in is whatever it's chained onto, self, right? It's self. So that's all that is, and then you give it, just like when you're writing a function, you can tell it whatever other parameters you want to pass in, and you can even default it as like no name. So you can set like default values to it. Let me see what that does. It should just say no name. Oh yeah. Yeah. So same with the functions, you can declare like default values as well. You can have more than one function or method. self name self dot name equals name. We'll do self dot. So that may make it a little more obvious what's going on here. This bit, because I'm basically saying that the instance object where this function is bound to it, and I could call that whatever I want, really, but we're not going to do that, just to keep things simple, is equal to whatever like variables passing. It's the same thing as a function, right? It's just indented inside this joint here, right? So again, I can do this, and if I do like class object dot age, this should throw an error. Yeah. Actually, it doesn't throw an error. It tells me where that bound method is, like in memory, like physically where it's at in the computer. So that's interesting. But as you can see, there's no variable assigned to it, so it's just kind of like, yeah, I don't know, dude. So likewise, if I'm not mistaken, this will actually fill out that information for us. I was mistaken. Oh, change name. I got the method call wrong. Yep, there we go. So this is what I mean by like mutable. So we've created like a data type here, and we've effectively changed it, right? Without, there's no like equal sign over here with some like variable, right? So depending on how you write your class, you can make it such that your class could be mutable in this way, or it could be immutable in this way, or not in this way rather. So that's pretty much the big idea of this module we just went through. Is you have variables and you have data types in Python, and a class is just a data type, and likewise with functions, you can call like methods on these classes. They're basically functions, and so I'm losing my train of thought. I'm sorry. You have data types in Python. You have variables. A class is basically a data type, and it's just like some functionality in Python that gives you the ability to basically declare your own data types. In the same way, there's rules about how you can handle like integers and strings and so on in Python. When you're creating a class, you're creating rules about how that new data type that you invented can be handled, right? So methods, I keep making this association with functions because that's literally what they are, as functions. But there's also attributes. Don't know if this is at all true, but I hope I'm not sticking my foot in my mouth and yeah. I'm blanking on how to actually declare an attribute. Oh, you do it under your init call. My bad. So you can see I'm actually not passing in a parameter for personality here. I'm just declaring it strictly. So that should, yeah, we're again gonna clear our console just so we can get all this joint. So when I call like that attribute, you can see it just like directly goes there. I don't have to call a function on it in the first place to declare that. So to really drive home the point, this throws me an error for, again, I assigned a default value for name, so that doesn't throw me an error because we have a default value for it. But there's no default value for age, and so that just tells me where that method is in memory via where that class is, or that class object is in memory. So the class doesn't exist in memory. I should be clear about that. But the actual instantiation of that type of class, that the object, exists physically, like in memory on my computer right now somewhere, and that's all this stuff is. You don't really have to worry about being able to read or interpret that necessarily. But so you can see that for personality, it just if let's go ahead and comment all that out. I don't have to declare it or anything, right? It's already there. So that's what an attribute is stop. I think of attributes as basically like variables that are assigned to a class, like by default, versus methods you have to have an argument passed into them, right? So that's why you get these parentheses here at the end, is because you have to actually pass an argument into a method because it's a function, versus attributes are just variables. So the same way, like if I have, you know, my list and it's equal to, it's not a string, but you know, some list of stuff. I don't know why I'm bothering with typos right here. I can later on just call my list and it's just going to return that list directly, versus if I have my function and it requires me, if I'm requiring it to, or just anyway, so I have a function and I'm required to pass in some lists, and then so I can't just call my function directly. It's gonna throw me an error, right? Because it's like, I don't know what you're like wanting me to do. So I have to actually pass in some argument into it. It doesn't really matter what I'm doing to it. I just want to. Oh. Didn't declare. It as a, I hadn't declared like the function yet. Okay, let's try that now. list object has no attribute join. So this is a great example of a list is a class in Python, and this method, which I guess you're supposed to use on strings instead, is not available. So in the source code of Python, there's like something called class list, and there's some function written in there somewhere that tells it like you can call like dot join on, I guess it's a string type, but not for list types, and so that's why I'm getting this error. It says has no attribute dot join. It's calling it an attribute for some reason. We won't get into like the minutia there. I just want this to run to show my point. Yeah. So dot pop just like takes the last item in a list and returns it. So that's all that's doing. But the point being that if I just call the function, it's not going to do anything because it needs arguments passed into it. And if you were in like a better IDE, this would like print everything else out except that last one because that's where the error is being thrown, but it's LeetCode. So you pass in an argument and it works. So that's basically it. You got classes, which are just data types, and then you have methods for your classes, which are just functions that are exclusive to that class or data type, and you have attributes, which are variables, essentially, that are bound or exclusive to that data type. So like, maybe like, so one like attribute might be, you might like have a class object that has an attribute that is a dictionary of the methods that can be called on it, and it's just there for your reference if excuse me, if you want to like troubleshoot like the thing with the join method I was trying to call earlier. So you would just call like, that class object dot whatever the name of that attribute is, like myDict or whatever, and then it would print out this dictionary with all that information that you want there. Same thing as if you literally just had like, some myDict, and then you had like a bunch of key value pairs, and then you just called like myDict, right? So that should be an equal sign. I'm not going to run this anyway. But so an attribute is this, basically. And when you call it, it gives you this, right? It could be a list, could be an entry, could be whatever. And a method is this, basically. And when you call it, it does all of this. So that's basically object-oriented programming for you. It's not that Python is written like to strictly operate this way. You can also write it with other sort of paradigms. Object-oriented programming is, like the orient word kind of like gives it away. It's like just a certain way of thinking about things and like organizing things, right? And Python just has some built-in keywords like class and def and some of these magic methods like the dunder init thing, that allow you to organize your code in that way. But theoretically, you could have like a functional program with like object-oriented aspects to it, or vice versa, or like whatever. But the big idea here is that this allows you to write repetitive operations, or give the computer instructions that themselves are repetitive without you yourself repeatedly typing the same thing over and over again, because now you can just call like that class or that method or whatever instead of having to rewrite entire blocks of code. In that same vein, you also have this thing called inheritance, which I don't know that I'm going to demonstrate all the code right here, but basically, well, maybe I will, I don't know. Cool. So if I had a class and I wanted to call it person, give it an init method. Init just means initialization. Unknown. We'll give it a default age. Let's do -1 because nobody's -1 years old. I hope that doesn't. Yeah. Okay. Let's do like hometown. So for each one of these parameters that I'm passing into the init method, I have to actually, I've given default values for all of them, so I'm not gonna do that. What's like a default attribute I might give them? Human. So yeah, self dot species equals human. Trying to think of another good one. Self dot diet equals omnivore. So we're just gonna assume that even if you eat vegetarian, you're still physiologically at least an omnivore, right? So that's our person class, right? And I hope I'm getting the syntax on this right. Let's say individual person inherits person. And now I can give it a function to change its name. Same thing for age. Self hometown self dot hometown equals hometown. Okay, so assuming I got this syntax right, actually I'm gonna go Google this real quick, just because I don't want to troubleshoot it. Actually, because that's gonna take an eternity to load. I can't believe this is a 45-minute video already. Oh my god. We're going to I wonder if just give me 1 second and I'll get the source going. Oh my god. I need a desktop computer desperately. So I should mention that all this is loading. Well, you can't see what I'm looking at right now, so I have to. Oh my god, my whole computer's frozen. We're just gonna be patient and wait for this to load. There we go. So like that first class I declared is an abstract superclass, is kind of what it's referred to. Okay, that's what I needed to know. Why is my video... It's always something, man. What the heck? Because I minimized it, that's why. Okay. It's dumb. Super dumb. Yeah, I agree, Zeus. He's over there moaning. Anyway, so we have to let Python know that we're planning on passing objects into this, basically. And we don't need the parentheses there, just the one. So let me make sure that runs, yeah, with no errors. So that means the syntax here is at least good. So basically this is set up with the intention that you're never going to actually initialize this class, an object of this class. You're just preparing this so that any object of this class that you initialize is going to inherit some things from this, right? So let's do me equals individual person, and I believe when I initialize it, let's play with this a little bit. Yeah, cool. So let's do print zef.h. I guess I do need to do all that. Yeah. Okay, so you can see that the Zeth object that I initialized is this class object. But when I call .age, it's giving us the default value for the person class object here. That's because we're passing the person object into the individual person class object when we define that class. So everything in the individual person class, in this class here, the subclass, subclass, inherits from the, sometimes they mention it as an abstract superclass. So the difference between a superclass and an abstract superclass is just how you use it. It's not an actual difference in how you code it. Sometimes you have superclasses that are like initialized, and then you have subclasses of those that are also like initialized. An abstract superclass is one like this, where you write it with zero intention of it actually being used as an object itself, but just to provide inheritance to a subclass. So if it's an abstract superclass, that means that it's not meant to be initialized itself as an object at any point in time. But if it's just a superclass, no abstract superclass, then like it is going to be used just like any other class and probably will be initialized as an object somewhere. That's just a way to like speak about it in natural language. So like I said, there's not any real difference in how you write the code for there. Point being that this class inherited this information from this class here, right? And you could inherit from multiple classes here if you wanted to pass that in. That gets really complicated and weird. But there's no method bound to the person class type to actually change any of that information, right? So if I wanted to do, let's see, Zeth dot change name to oh, we did age, so we'll demonstrate that first. Change age to 25. Print Zeth dot age. So this should print out for us a -1 and then a 25. Yep. And that's because we called the method on like the individual person class. But so we can't really like do that with the person object because A, like there's no method bound to it to do that, but also B, we haven't initialized that class object anywhere. We've only initialized this class object, assigning it this variable name. And likewise, you can do that for like hometown. Name. No? Yeah, name. So say I wanted to add like my last name. I don't know how smart it is just to broadcast my info on the internet like this, but it's not that hard to figure out anyway. Yep. So you'll also notice that I'm calling to get that information from, I'm calling like object dot method, right? So that's dot name. So there's actually no like there's this method that exists that allows me to change that information about the object, but the attribute itself comes from the person object, right? I'm not calling like individual person object dot name. I'm calling person object dot name, right? So I'm manipulating the value of this variable, if you will, and remember an attribute's a variable basically. I'm manipulating that attribute with the method here, but the attribute itself comes from this class object here. And so this whole like principle of being able to call attributes from your superclass and being able to actually manipulate them with your subclass, that whole idea is called polymorphism. So if you want to know more about that, if you made it this far in the video, you can Google Python OOP polymorphism. You'll probably find some good stuff there. Cool. Okay, so this is getting like way longer than I intended. This is like live stream length. So there's one more thing that I want to demonstrate here. Um, Nickname equals self. So say I wanted to get a manipulated version or a mutated version of some attribute, but I didn't want to actually mutate the attribute itself, the variable itself, right? Um, I should maybe think about these videos ahead of time and like plan them more. I'm probably not going to though. Yeah, that'll, I think, illustrate this. So if I call my object and my method call, so for my nickname, what I want to do is I just want to make all the letters uppercase. It's not really a nickname, but you get the idea. So I'm going to pass into here just the name. All right, well, whoops, okay. Yeah. There we go. So as you can see here, what's going on is I'm actually like passing in the name attribute as an argument for this function. And I'm returning a manipulated version of that attribute without actually mutating the attribute itself, right? And that begins to kind of point towards this difference between mutable and immutable data types in Python. And I don't want to get too much more into the weeds there because, like I said, this video is already super long and I could go on forever about that. But that, I hope, just sort of illustrates the idea that depending on how you code your class types, depending on how you design this new data type that you want, you can make it so that it the values themselves are editable or not, and you can make it so that those values can be like, you can see what edited versions of those values are without actually editing the values themselves. And that becomes a lot more important when you start talking about actually object-oriented libraries like scikit-learn, which we are going to learn a lot about in this phase. Or we're going to use scikit-learn a lot in this phase. So to bring all that together, like they did in this module, you have in scikit-learn library, you have 4 main classes. So if you've used pandas or matplotlib before, you know that you'll have like plot dot something. Plot's an object type, and then dot is like whatever kind of method call you're calling on it. Usually it's like some sort of graph or something that you're calling on it in matplotlib. Pandas same way. So like pd.concat, like pd is an object type, and then concat is a function that's concatenating like 2 data frames together. So when you look a little bit more into OOP, like a lot of the syntax and things that you see in different libraries that might look unrelated at first, when you like learn OOP a little bit, they start to like seem a little bit more similar to one another. So anyway, in scikit-learn, you have 4 main class types. You have estimators, transformers, predictors, and models, and they all sort of have different methods and attributes even that are unique to them, and they also share some of those methods. So in scikit-learn, it gets a little weird, and they use this thing called duck typing, which is just kind of like this reference to the idea that if it quacks like a duck, it's a duck. A lot of the different class types in scikit-learn have the same method calls available to them. Even though like in the source code somewhere, like it's separate classes, like blocks of code with classes, and they have separate like blocks of code with the method calls defined and everything, but they're the same thing. It's like dot fit parentheses or dot score parentheses, whatever. Some of these class types share method calls with other ones, and there's some method calls that they don't share. So that was kind of their main point with scikit-learn at the end of this phase, was that it's an object-oriented, a library is designed like with an object-oriented paradigm in mind, and there's these 4 main class object types in scikit-learn, and they kind of have some overlap in terms of the methods that they can call. And my intuition is that they sort of inherit from one another, like you see here, because there's like estimators, which only have like a dot fit method call. It has other ones, but like mainly there's like the dot fit, and then there's other class types that also have that dot fit in addition to other like methods. And so I wonder if it's just like similar blocks of code in like different like class declarations, or if they're actually inheriting, like transformers inheriting the dot fit like from estimator and like that sort of thing. But yeah, so very long story short, that is what I learned in the first module of, let's get back here, of module 21 of phase 3 of the Flatiron Data Science BootCamp. Like I said, like I was already pretty familiar with like the ideas and everything behind OOP. Obviously, like I don't like, I kind of like, I can go on like code like this all day long. I should maybe brush up on my syntax a little bit, but I hope that this demonstrates that I at least like understand conceptually what I'm talking about. Yeah, so I'm really excited to see how OOP can be used in a machine learning context. And the idea that you can kind of like define a class or an object type and hand that to the computer, and the computer sort of like learn and decide like for itself like which objects to use and not use, and in what ways, and like what methods to call, and like I don't know, like we did like the linear regression model in the last phase, and now we're like really getting into the weeds of like machine learning type stuff, and I'm starting to like get how, I know like I've understood like before how like OOP sort of plays into software development, but like machine learning from a I've only really known about it from a distance so far, and it's most of the type of programming that I've done so far has been functional, which is like, so you can imagine with like OOP, you're referring back to like other blocks of code, like where the class and like methods are like defined and everything. Um, Functional programming is kind of just like strictly like a list of instructions just going down the line, more or less. I'm not gonna get into that because this is gonna be like another hour. But versus like OOP is a little bit more dynamic in that sense that it's not just going straight down the line. It's kind of going here and then over here and then back over here and then back down here again and then over here and that sort of thing. So yeah, I don't know. I'm really excited to like learn about how OOP plays into developing machine learning models in this phase. I think that's going to be really interesting. A little anxious about we're going to get even deeper into with the math stuff, and I'm like, my brain is good with math. Like, I pick it up quickly, but I just didn't embrace that for so long in my life that it wasn't until like, it was like, a couple years ago that I really started to be like, I should, math's kind of interesting actually. And let me like, learn about this. So there's a lot of just like foundational math stuff that I feel like I missed out on or ignored earlier in life, and I'm having to like relearn a lot of like the basics. So that makes me a little anxious with getting even like deeper into like the like heavy math content. But that's what learning is all about, right? So it'll be an adventure nonetheless. So anyway, I hope you found some value in this video. I don't really care if you scroll through it or not, or watch like all the way to the end. Mostly this is for me to practice. I think it's the same way I was saying at the beginning of the video. It's helpful for me to write down by hand these things. It's also likewise very helpful for me, like for my learning purposes, for me to sort of say these things out loud. Yeah. So, I think that pretty much covers everything on my little like summary sheet here. I'm gonna do another video like this later on, hopefully much shorter. Maybe I'll like script it out a little bit next time. I don't know, probably not. But yeah, I'm gonna do this for every module in the phase, and there are looks like 10 modules in the phase. So there'll be about 10 of these videos going into like all these different topics that you see here. Just going into like kind of my understanding of those topics. And I'll also be, I've been doing some live streaming. It's going to be not until I finish those 10 modules that I start working on the project again, which obviously like I'll live stream like those coding sessions when I'm like working on the project. But right now, like there's not really anything else for me to share other than like this sort of stuff, which is, like I said, that's course content from Flatiron, so I don't want to just like be throwing that all over the place. You can find it on GitHub for free if you look hard enough, but lead a man to fish type of thing. Yeah, and it's kind of boring. It's really more of like a code along. It's not like I'm sitting there and like really like figuring out like problem solving and stuff. So what I think I'm gonna do is get like I've been getting into the habit of leak coding every now and then, and I'm thinking maybe like once or twice a week getting on leak code and live streaming like some leak code sessions. I think that would be a lot more interesting than me like working through a lab module, because like I said, that's mostly like a code along thing versus like leak coding. I'm actually like thinking and like figuring stuff out and whatnot. So yeah. Anyway, if you survived this long in the video or even watched a tiny bit of it, I really appreciate it. I hope that you got something out of it, and I hope that you will come back and see it next time. If you have any questions about OOP, or you just want to be pointed towards some like helpful resources or anything to learn that sort of thing, you can comment below, send me a DM, like whatever, and I would be happy to share with you whatever that I can. Yeah, so until next time, you guys have a good one.